for the invitation and introduction. I'll make you could say, a short introduction to how we are going to develop the energy sector for the coming 10 years. And it could be some kind of a ride. I don't know whether tree canoeing here is scared or looking forward to an enjoyable ride. I know how I would feel if I was staying there. But anyway, I really look forward to the coming 10 years. And I'll take, you could say, two short introductions. One is really the economic part of it. Why should we go towards a smart energy system? And then with one single example, and I'm quite sure that Emil afterwards will tell much more in detail how you can use technology related to that example, because it's around electric vehicle. And then I'll take a bit more time on, you could say, some of the threats going towards smart energy system, the cyber issue we have around that. If we look towards what we're really working on, is we have this climate target, or this national target, the 70% reduction of carbon emissions in 2030. Well, the target is to reduce emissions by 17% compared to 1990 emissions. And just a few figures on that. We have reduced with 35%. So, well, anyway, we have used, let's say, 30 years to go half the way, and now we have 10 years to take the second half of it. And to be honest, I think we have, hopefully we have taken a lot of the easy solutions. So now we have all the difficult solutions. Of course, you could say, during these last 30 years, computer technology, digitalization have evolved a lot, and I think that that's really what we need to go, you could say, to take the last and very, very difficult step. One of the reasons that it's quite interesting in the electricity industry is that there is a quite clear forecast that electricity consumption need to double from this year, 2020, to 2030. So we really have to increase the consumption of electricity by a factor 2 in 10 years. And that's a huge challenge, because you cannot build an infrastructure, a traditional infrastructure, to handle this increase in consumption. And why should we increase consumption so much? Well, we have to substitute a lot of fossil fuel. And one of the obvious ways is to change from fossil fuel driven vehicles to electric vehicles. And one of the forecasts is that we need to have around 1 million and 1.5 million electric vehicles in 2030. And that's a huge challenge to incorporate them into the energy system. And we also need to change a lot of gas and oil heated houses to heat pumps. And these heat pumps can be on an individual level, and it could also be into, you could say, the district heating system. And if we have, and we need to succeed with that, and that really basically implies use of smart grid technology or smart technology. We have this climate partnership for energy, and that delivered their report in March this year. And then they had actually made, you could say, a full forecast how to fulfill this goal. And it's a huge report, and I'll be happy to send it you afterwards or link to it. But they have really seen what is, you could say, if you look into the traditional grid infrastructure, what kind of investments do you need towards 2030 to fulfill the requirements that you can supply the double of electricity consumption? Well, if you have, and if you start on the left side, if you have the traditional consumption, and just say, well, we have to, you could say, refurbish, develop the system towards 2030, but with no increase in consumption, that is actually a cost on around 56 billion Danish crowns. That's really the cost for running the existing infrastructure, just to you could say, service the existing consumption. Well, now we need to double the consumption, so we end on around 70 terawatt hours. If we, you could say, use smart energy technology, and I'll give you a single example on what that could be later. The need for investments in this infrastructure is around 20 billion Danish kroner, or 23, which means that in this infrastructure sector, we need actually to invest using smart energy technology, nearly 80 billion Danish crowns towards 2030. Well, that implies that we use smart energy technology if we allow, you could say, the new consumption to use the grid as dumb devices. We actually have to increase the investments to 110 billion crowns. So I tend to say there is around 30 billion good arguments for using smart energy technology in this development. And to be honest, even if you had all the money, or even if you think, well, I like the old technology, I want to do it the old way, to be honest, we cannot build this infrastructure in 10 years. So we need to utilize smart energy technology all the way around. And I'll just give you one very brief example, and I really hope that Emil will go into details on that. I expect that. I haven't coordinated it with Emil, but I know him very well. And I apologize that some of the figures here is in Danish. But really, what we mean by doing it smart. This is a typical consumption curve for a household. The dark green here in the bottom is the typical consumption of a normal household, which means that you sleep during nighttime, getting up in the morning, start to utilize your electric devices, go to work, and then when you come home in the afternoon, then you start your cooking stove, and that's really the device in your house that uses most power. And we tend to cook at the same time in Denmark, everybody. So we have the evening peak here when everybody is cooking. And that really, it's really the peak that demands the capacity of the grid. If you put in a heat pump into a household, let's say this household have either a gas heating device or oil device, then you put in a heat pump. It has a more, you could say, constant energy consumption during the day. It can be more flexible. I'll not spend time on that. But if you take a typical electric vehicle, that what really happens is that you park it during the afternoon, and then you just plug it into your charging point, and then it will typically charge at the evening peak, which means that you have to increase the grid capacity. And that was really what I called the dumb scenario. That's where you needed the 110 billion Danish krone in investments. If you can do it smart, level it out during the nighttime, because we basically need our vehicle the next morning. We don't need it 9 o'clock in the evening. We need it 6 or 7 o'clock in the morning. That really reduces the need for capacity in the grid. And I hope Emil will tell a bit more about what you need to do to fulfill this. And it looks very easy on PowerPoint. I think the technology is available, but there's a huge challenge also to get the user involved and get their acceptance of letting out some of the control of their consumption. But that's doable. And that's really what, if I should say, that's the smart energy thing. And then I'll switch to, you could say, the challenge around that. And that's really the cyber threat against the energy system. Because if an electric vehicles, 1 million electric vehicles get controllable, then they can also be hacked. And the challenge is you get a really brief introduction how to an energy system runs. It has to be in real-time balance. That was the old system. When you plugged something in, then you just started the power plant to increase the production to fulfill the consumption. The new system is that we're going to have a lot of flexible devices, wind turbines and PV production, and we cannot control, you could say, the outcome of that in the same manner as a power plant. And the smart energy thing is really that now a lot of our devices, the electric vehicle, the heat pump, becomes controllable. And I think a lot of you will be familiar with the IoT term. So really, and that will be internet connected. And that's really a challenge for an infrastructure provider like us, because we used to have full control of this system. And now a lot of these devices are getting into the internet. And who are ensuring that, you could say, that these devices are compliant with the highest security standards? because they're not a part of the infrastructure owners' control. They're part of the user's control. And when I am on cyber seminar, I tend to ask people how many are ensured that their Wi-Fi connection point has the largest patch, has the largest firmware. And I think the record is 30% of the attendees. And what can happen if somebody gains control of all these small devices? Well, this is how you could say security of supply is in Denmark. We have the best system in Europe, or nearly the best system in the world. We have a very small interruption. Then you see we have 3 years where we have, you could say, large interruptions. And all of these interruptions here in the bottoms, that's around between 1 and 2,000 smaller interruptions in the lower voltage grid. You have something digging over a cable or something like that. These events is a single event. That's an event on the transmission system where you get you could say, a cascade effect in the system. So where this is a result of 2,000 events, this is the result of a single event. And actually this one was due to some digital communication issues. And that's really what happens if you gain control of 1 million electric vehicles. That's where we can end. And the traditional system has no control on these devices on the cybersecurity level. And that's really the question. How do we build this system where there is about 30 million good reasons for doing it in smart energy? How do we build it safe? Because it's not me as an infrastructure owner that should be ensured that can ensure that the electric vehicle is updated to the newest security standards. I cannot assure that this privately owned devices has the latest security patch. And that's really one of the big challenges, and I hope some of the attendees or some of the other panels have good answers on that, because otherwise we were not going to harvest this economic benefits on 30 billions, and we have to do that for the society. I think that was a very brief introduction to how smart energy systems and 30 billions of good reasons, and maybe some challenge around cyber.
Yes, thank you very much, Jørgen, and right on time. That's amazing. There were some questions we also could take to the debate later on about incentives and how to do it, and the question about security. That's maybe also some questions that Stefan and Emil will address. So there's no initial questions in the chat, but remember